Thank you, Jim. So guys, in the last classes, we have done with this two command line, right? So we have done with the VLAN, right? What is basic, right? And also we have configured the, switch port, access, VLAN number 10. This command we have done. So hope you have cleared this command line. So we just discussed about this part, right? And we have seen that what is VLAN. That's it. Now take example. We have a switch one, right? And we have a switch two over there. All good. And we have some host behind the search one that I can say that this is the search one host PC1, and we have a PC number two as well as right. At the same time, we have a PC number one. Some different location we can say that on the some different building we can. So this is the first floor. We can assume like this. This is the first floor, and this is the second floor, right? And this is the search one. This is the search two. Yeah. This is search two, and this is the PC number one. This is the PC number two. This is the PC number three, and this is the PC number four, right? And we have a Ethernet connectivity between this guy to this guy and this guy to this guy, right? The same thing we have this guy to this guy and this guy to this guy. And after that, we have a link between the switch one to switch two. By default, as we know that, by default, as we know that all we have a single VLAN, right, on a switch side. So 0/1 and 0/2, 0/3, right? This is 0/3 now. 0/1, 0/2. All good. So this is the first floor we have. This is the second floor we have. This is the switch one 0/3, 0/1, 0/2. All good. And by default, right, switch has single win. Guys, if you haven't attended the last class and if you have not watched the last videos, my suggestion is that leave the class and go and watch the first videos. Otherwise, you will not understand. Okay. So by default, switch has a single VLAN that is called as a VLAN number one. Right now, all the interface by default, all the interface is the part of the VLAN number. So right now, if you take example, we have a VLAN number one, and in this VLAN number one, we have a 0/1, 0/2, right? And we have a 0/3. This is the right now the database of VLAN, and same thing. This is the database of the VLAN number. Switch to as well as what I'm going to do over there. I'm going to make this interface right. I was a VLAN number 10. So I said that okay, you are the belong to the VLAN number 10 now, right? And this should be the VLAN number one, the default one. The same thing we have a VLAN number 10, right? And this is the VLAN number one. All good. So we can. 1 minute. आगे. Yeah, sorry. So this is the IP address we have. So the IP address of this person, we can say that this is the layer 3 address, or we can say that this is the logical address, the MAC address A. Yeah. So this is now the B, and this should be 1 or 2, and this should be 1 or 3, and this should be C now. Okay, and you will go for the D, right? And the 1 of 4 IP address. Try to understand. I'm going to make this interface 0/1 is the part of the VLAN number 10 now. So the VLAN number 10, we have this interface 0/1. So this interface will be removed from there, right? And it will be present in the VLAN number 10. Same information I will put in the switch 2 side, right? So we have VLAN number 10 and 0/1 interface. So this 0/1 will be removed from the VLAN number 1, right? Like this right now we have. So in this case, if the PC number 1 will send any packet, for example, the PC number 2, we say that, hey, I want to send out traffic, right? The command I'm going to use the ping 10104, right? If I'm going to send the packet ping 1104, what happened? It will create a, first of all, what happened? This ICMP packet will drop at this point, right? Because the ARP entry is empty right now on the PC2 side. The PC number 2 will create an ARP packet. In this ARP packet, what happened? The source MAC address will be B now. Destination MAC address will be what? Right? Right now, and source MAC will be what? Again B. And destination MAC 000. Source IP will be 101 now. This guy destination IP will be what? 104. Right? When this packet will come on 0/2 interface, what switch one will do on this particular 0/1 interface? I'm going to learn the MAC address is what? Sorry, 0/2 interface. I'm going to learn the MAC address B, right? And after that, the look up the destination MAC address. The destination MAC address is what? It's a broadcast. So I will perform the broadcast on which VLAN? VLAN number 1, right? So on which port I'm receiving the packet 0/2. So I will send the packet from 0/3 now. Once the switch 2 will receive this packet, it will learn the MAC address. Okay, 0/3. I'm going to learn the MAC address is what? B on this particular interface. The source MAC address I'm going to learn over there. And destination MAC is what? FFF. Again, I need to perform the broadcast in which VLAN? VLAN number 1, and it will send the packet to whom? This guy. It will give the reply, right? And he will give the reply to the switch 2, switch 1, and switch 1 will give the reply to the PC number 2 now. And they will learn the MAC address. Okay, the DE is associated with the 1.4. And after that, they can send the ICMP request, and reply will come like this. This is how the communication will happen that we have seen in the last class, right? But take example, it means that they can communicate to each other, right? It means this guy can communicate with this person. If you have a look, okay, the Cisco packet ratio. Hey guys, please be on the time. It's a request. So mic भी बंद कर लो, ये भी request ही है. PC1, PC2, PC3, PC4, right? And we have a switch 1, switch 2. Given. All good? Now, if you see, same topology I'm going to draw over there, right? Ganesh,
Yes, sir.
your mic on. VLAN number 10, right? And this is the VLAN number 10. So this guy's IP address will be 101, this guy's IP address will be 102, this guy's IP address 103, this guy's IP address 104. This is the VLAN number 10, this is the VLAN number 1, this is the VLAN number 10, and this is the VLAN number 1. All done. And now let's do one thing on 0/1 interface, right? On this guy, right? 0/1 interface, this guy. So should be a part of the VLAN number 10, right? So I'll do one thing, I'm just gonna switch 1 and say that interface 0/1. I say the switch port access VLAN number 10. Do I have a VLAN number 10 over there? No. So what happened? First switch will look up, hey, do I have a VLAN number 10 in my database table? The database table is called as a VLAN.dat file, right? This is the database table for the VLAN. If the VLAN number 10 is present in this database table, right, then it's fine, right? Otherwise, what happened? The switch will create a one VLAN. Let me create a one VLAN. And after that, what happened? If you see, do so VLAN brief. They'll make up this interface as a part of the VLAN number 10. Same thing I need to do on the system. Switch to this interface, which interface? 0/2, right? CLI. And if you see, I don't have any VLAN, so I'll just go on the interface 0/2 now. Switch port access VLAN number 10. I don't have a VLAN, so let me create first of all, right? Access VLAN does not exist, create the VLAN number 10. And all good. Now, if you have a look, if I'm going to send the packet, right, from this guy, the VLAN number 1 to this guy, it works. Can you see that the first ICMP packet will drop just because of the encapsulation failed, right? And after that, it will create the ARP request packet. And in the ARP request packet, what happened? The source MAC address of this MAC address, right? The user MAC address, destination MAC will be broadcast. Source IP is what? This guy 102, and destination IP is what? 104 when I'm sending the packet. Packet is coming to the switch 1. Switch 1 will learn the source MAC address, and then it will perform the broadcasting into the VLAN number 1. This guy. And what switch 2 will do? Switch 2 will learn the source MAC address on this particular interface. It will send the packet to the VLAN number 1. It will receive the packet, and what this guy will do over there? First, they will learn the ARP entry of the source, right? The 102. This is the MAC address of 102, and I'm learning this ARP entry as a dynamic way, right? So we have two types of entry. Either you can have a dynamic entry, or either you can have a static entry, right? For the dynamic entry, we have some timer. For the static entry, there is no timer. And now it will give the reply packet. Reply packet always do the unicast. So if you see that, the reply is totally unicast packet. Right? It's a unicast packet. Now the switch 2 will learn the MAC address, and it will forward the packet to whom? Switch 1 based on the MAC address table, and switch 1 will send the packet to the PC number 2. And once the PC number 2 will receive the packet, what happened? Now this guy will do the ARP entry mental. So now 104, this guy has a MAC address. This guy learn this information as a dynamic way, right? I'm on a PC number 2 now. And now after that, this guy will send the ICMP request, right? Go to this guy, then this guy. And reply will coming via this guy, and this guy. So in a PC1, right, what I'm telling you guys over there, they can easily communicate with this person. No issue. We don't have any issue with the communication. We don't have an issue with the communication between the PC number 2, the PC number 4, because these two guys are posing the VLAN number 1, right? At the same time, this interface as a part of the same VLAN. Same thing, this interface and this interface are the part of the same VLAN. That's why they are able to communicate over there. All done. But what about this person now? If you have a look, this guy, can I communicate with this person, VLAN number 2, the VLAN number 10? They are the same VLAN, right? But they cannot communicate. Reason, do you know? Because when this person, right, when this guy will send the packet, in this packet, what will the source MAC address? Because the first ICMP packet will be dropped, because I answer the ping, right? 103, this guy from here to here, right? So the first ICMP packet will drop. Then after that, what happened? It will generate the ARP request packet. In the ARP request packet, source MAC address will be A, destination MAC will be FFF, right? So then in the ARP header, we have a source MAC address. Destination MAC will be what? 0000. Source IP will be what? 101. Destination IP will be what? 103, right? this packet, the PC1 will be generated, right? This is the ART request packet. The PC1 will generate. But in this ART request packet, what happened when this packet is coming to this guy, 0/1 interface, they will launch the source MAC address. Okay, the 0/1 associated with the MAC address A. The destination MAC is what? It's a broadcast, right? FFF. So what switch 1 is going to do? Switch 1 is receiving the packet on this particular interface 0/1, and 0/1 is the part of which VLAN? VLAN number 10. So where should I broadcast the packet? Into the VLAN number 10. Do I have any ports over there? No. So the packet will be dropped over there. I don't have a port, so no communication will happen between this guy and this guy. What is the solution we'll have, guys? The solution I can have, what I can do, the solution, I will take a one cable and provide like this. And I will make this interface as a part of the VLAN number 10. Like this. So this guy will carry the VLAN number 10. This guy will carry the VLAN number 1 traffic. So now this interface, we have to connect the another cable 0/4 over there. Same thing in this case, right? Now I can set the traffic. It will work. Now it work. If you go and check over there right now, if I'm going to send the packet now, take example. Okay, right. And let's restart again and send the packet from here to here to this guy, VLAN number 10. ICMP will be dropped just because of the encapsulation field. R will be generated. You can see that from source IP address 101. That is this guy. Destination will be 103. Source MAC address of the 030, this guy MAC address. And destination MAC will be broadcast as we know that R request packet. When this packet is coming to the switch, right? What switch is doing? Drop. This is the spanning tree packet. Done. Reason is that this interface is only going to carry the VLAN number 1 traffic, right? So what is the solution we have over there? The solution, we can do one thing. I can take the another cable 0/4, right? And I'll make this interface 0/4 as a part of the VLAN number 10 or 0/4. All done. Same thing on this side as last 0/4. All done. So now if you see on the switch 2 now, we have do so VLAN brief. VLAN number 10, we have a 0/2 and 0/4. And same thing on the switch 1. Now it will work. Go, have a look. I'll pick this packet, send the packet to this guy, this guy, this guy, this guy, reply. Bingo. Okay, khatam. Done. Guys, let me know if you have any question till this point. All clear. HP, change your name. Otherwise, I have to call the HP. All good. Now, guys, think practically. What is the range of VLANs we have, guys? We have a 2 to the power 12 bit, right? Near around, we will get a 4096 VLAN, but you can create only to 124094. whereas VLAN number 1 is already reserved. Right? You cannot create VLAN number 1. Sorry, you cannot delete the VLAN number 1. You cannot delete and you cannot modify. Modify in the sense you cannot rename it. Modify means you cannot rename it. So take example, if you have a, listen to me, if you have a just 10 VLAN, if you have just 10 VLAN, right? How many Ethernet cable I have to require between the switch 1 and switch 2? If you have 100 VLAN, then see the problem. ऐसा है, there's a guy, okay. So, right now, understand this guy. This guy is planning to watch the Netflix, and इसके पास एक टीवी है. So this guy, what happened? This guy take a one Netflix cable. After some time, he said, "Hey, I want to watch the GTV." So he will take another cable, GTV. After some time, he said, "Hey, I want to watch the Hotstar as well as." खुद का अकाउंट इसके पास कुछ भी नहीं है मगर ये. After some time, he's saying that I want to watch the Amazon. So can you see that I have a separate cable for this one? Netflix, Z Prime, sorry, G, Hotstar, Amazon. This is not a good solution, man. Then I suggest these people do one thing, Amit. Do one thing. If you know watch everything, I'll give you the single cable. And in this single cable, now they can carry the Netflix, they can carry the Amazon Prime, GTV, and Hotstar as well as. Like you're watching the movie, how you're watching the movie on a single cable, they can carry all the type of traffic. Same thing I have to do in this case. Same thing I have to do in this case, right? I'm going to make this interface as a special type of interface. I'm going to make this interface as a special type of interface that can carry all the VLAN traffic. Make 0/3 and that interface is called as trunk. Trunk interface carry all VLAN traffic by default, whereas access port carry single VLAN traffic. So if somebody will ask you, hey buddy, what's the difference between the trunk port and access port? This is the one difference right now. This is the one difference. If somebody will ask you how many types of traffic, sorry, how many types of VLAN or access port can carry? Two types. One can be a data VLAN, one can be a voice VLAN. VLAN 10, VLAN 20, or you can make the same amount as well as if you want, like this. So on an access port, right? On a single access port, you can assign the two VLANs. One, you can assign VLAN number 10 for the data and VLAN number 20 for the voice. If you assign for the VLAN number 10 for the voice as well as you can assign it. Max to max 2. But the trunk port can carry all the VLAN traffic. This range. Okay. So now this person can communicate, right? And even if you have a VLAN number 20 over there, and if this guy's a VLAN number 20, and if these two guys wants to communicate to each other, they can communicate through this link. So what is the command to make this interface as a trunk? I need to go on the interface. I just need to call this guy's interface 0/1, 3 switchboard, right? Because this is the layer 2 interface. That's it.
Dot.
Yep.
Roll.
Question. Do you know this is good, right? Well, look, just I तेजा साई साउथ इंडियन है क्या तुम साई तेजा तेजा भाई it's good, but you know the problem is that the problem, take an example, this person also have a same MAC address now. VLAN number 10 same MAC address and VLAN number 1 same MAC. We can do that, right? We have seen this kind of we have seen this scenario as well as the second, third day of the class. We have finished this part, right? The duplicate MAC address. So now take example, if the PC number 1 is going to send a packet, right? The source MAC address will be A now. Destination packet will be C. When this packet is coming to the switch, what switch will do? It will forward the packet to whom? 0/3. On a switch 2, we have a 0/1 interface as the part of MAC address C and 0/2 interface MAC address C. What switch 2 will do? Where should I switch to? Where should switch 2 will forward the packet? This guy or this guy? This is my normal packet, right? This is just a normal packet. The switch 2 will get confused. Hey, I'm totally get confused. What should I do now? So second thing is what? After making a trunk, what we have to do? I need to perform a tag. Tag is something called like, identification. Like my name is Lakumar Shah. This is my identification. Every person, right? Every person has a name, and that name is identify the person, right? Same take example, you come to the network homes and you are enrolled for the CCI security. So you will have a one ID card. वैसे तो होता नहीं है. You will have a one ID card, and on that ID card, right, the course name will be CCI security, course name will be CCNP security, course name will be CCNA security. So whenever you're coming to the first floor, so what happened? CCNA guy will be going to the CCNA classroom, CCNP guy will go in the CCNP classroom, CCI guy will be going to the CCI classroom, based on the what tag. So what we have to do, guys, over there, I need to perform the tagging. For which person? VLAN. And this tagging is done by the dynamically. You're not going to assign over there. The network engineer not going to assign, okay, this is the VLAN number 10 and 20. This tagging is done dynamically on which particular interface? On a trunk interface. On this trunk interface, they will do the tagging. And this tagging is done by a protocol called as a ISL or 80.1q. Right? So tagging is done by whom? Trunk port. Access port does not perform a tagging. Done. They will just put the VLAN tag. VLAN tag is what? The tag is something called as a VLAN number. Like Aadhaar card, PAN card, passport, this is called what? This is a tag. So here will be a VLAN number will be a tag. For example, VLAN number 10 is a tag, VLAN number 20 will be tag, VLAN number 2 is a tag, VLAN number 3 is tag, VLAN number 50 is tag. These are the tag. And how many tags you will have? Depend on the VLAN range. Pitu, mangai kya? Okay, so these are the tags, right? All good? तो बैच मेरा जो बैच मेरा साथ हो जो बैच है यार दिमाग now understand one thing over there, guys. We have a two protocol. One is the ISL, one is the 80.1. Which one I'm going to use? Okay, to understand this part, यहाँ पे आते हैं. So tagging protocol. We have a two one. We have a ISL and we have a 80.1q. The difference between the ISL and 80.1q is ISL is a Cisco and by default it's enabled. And 80.1q is a IEEE standard. But you know one thing, even the Cisco is saying that, right? You have to go for the 80.1q protocol. Even the Cisco recommendation, hey, don't configure ISL, go for the 80.1q. The reason is that because ISL is going to add the 30 byte of extra header. 26 byte का तो हमारा ISL हो गया. Plus 4 byte will be a FCS, frame check sequence. Whereas 80.1q is just a 4 byte of header. In a normal language, if you don't understand this part, understand this thing. Rohit, Nidhi, right? So Rohit is living in the, sorry, Rohit is living in the Bangalore location right now, and Nidhi is living, आजकल Delhi आ गई है अपनी, Delhi. Okay, so this guy has to, gift some phone. So they have purchased the one iPhone 12, and this guy has to, gift this phone to this girl. So what happened? We have a two courier service. One courier service this guy, and another courier service this guy, right? So in that case, what happened? We have a two courier service. So if I'm going to use the ISL courier service, right? So what ISL guy is doing over there? So this is the phone, what we call over there. The weight of this phone is 500 gram. Take example. So if I'm going to use the ISL service, so what ISL is going to do? ISL will encapsulate this phone, right? They will put this phone into this box, ISL box. So if I'm going to put this phone into this box, so what is the kg right now having? 30 plus 500. 30.5 kg right now, the courier service they are going to charge. So now the courier service is going to charge 30.5 kg, right? For the services, right? But if I'm going to use the 80.1q, they will just charge what 4.5 kg, because the size is 4 byte. So if I'm going to send this one, so what happened? If I'm going to use the ISL header on an Ethernet link, it's just a totally of wastage of bandwidth. And overhead will be increased. Can you see that over there? 30 byte extra header I'm adding over there. So overhead will be increased. The performance of the device, right, will be decreased. It's not a solution. It's not a good solution. By default, ISL is enabled on the Cisco device, but again, Cisco recommendation, hey, dude, go for the 80.1q because this is better one. There you go. Cisco ISL. ISL stand for Inter-Switch Link Protocol. IEEE 80.1 trunking between the switches. ISL is a Cisco provider, and 80.1q is IEEE standard. Trunking is a way to carry the traffic from several VLAN over a point-to-point link. The trunk link is called as a point-to-point link between the two devices. Eh? Indian Super Link. क्या मैंने क्या क्या लोग बहुत खराब थी done. Whereas so love it. I'll explain you this part. Don't worry. I'll just try to show you the size of the device, right? So it's a 4 byte. Solar 16, sorry, 16, 3, 19, 19 plus 1, 28, 20 plus 12, 32 bit, 4 byte. So even the Cisco recommendation, go for the 80.1q. The reason you have seen, right? And this is the header of 80.1q. In this header, the TP ID, right? It's a tag protocol identifier. Tag protocol identifier. क्या होता है ये? If you remember one thing, मैंने Ethernet type में, if you remember Ethernet header, right? We have something called Ethernet type, right? Remember 0x0800, then we have 0x0806 ARP IPv4, then we have a 0x 8847 MPLS unicast, then we have a 0x8848 MPLS multicast, then we have a 0x8100 the 80.1q protocol. This TPID is the same thing. What is the size of Ethernet type order? 2 byte, right? 16 bit हो गया यहाँ पे. So this TPID is just going to tell you, the TPID is just going to tell you what is the next level of header. Where should I forward the packet? So तुम्हारा कैसे बनेगा structure पता है? Take example. If you have a source IP address A, or, sorry, source MAC will be A, destination MAC will be B. Take example. In this one, your Ethernet header will be 0x8100. That is going to represent I need to forward the packet to whom? VLAN 80.1q protocol, right? And then after that you will have a this one TPID, and this 16-bit what happened? You have a 0x0800. That's the IPv4, and then after that this 3 bits is going to represent the quality of service. We'll see that in the advanced lecture. Like you based on this 3 bits, you can prioritize the traffic. Okay, this traffic go will first. Take example, if the router will receive 2 types of traffic, one is to receive the we can say the voice traffic, and one not router, the switch. It's a switch, right? And when I'm going to receive the data traffic, so I can inform to the switch over there, hey switch, listen to me. If you are receiving a voice traffic, you have to first allow the voice traffic on this particular interface. Once you have done with the voice traffic, then you can go for the data traffic. That is called as a prioritization of the traffic, and that is done by the 3 bits, right? Somewhere you will find like this name as a cost. Sometimes this guy's name is a cost over there. Class of service. This guy has a different name, PCI. What's on the full form of PCI? Priority code point. Both have the same meaning. You said 3 bit, which is refer to the 80.1 class of service, right? Some guys is referring to the class of service. If you go for the Cisco docs, they will return like a class of service. Then after that, we have a 1 bit. This 1 bit is going to represent a CFI, canonical format identifier. Again, if this guy is giving the different name, drop eligible indicator over there. What this guy is going to do, class canonical format identifier, this guy is just going to make a compatibility between the Ethernet header, right? Ethernet VLAN that we are learning right now, and token ring VLAN. In the Ethernet VLAN, it always set to the 0, always 0 rahega. This 1 bit, and the next 12 bit, right? This guy. So this always set to the 0, right? And by default, it always set to the 0 if you're not going to do any quality of service. And then after that, we have a 12 bits. That's 12 bit is what? It's a VLAN number, right? The size of VLAN is what? 12 bit. So now after that, you have a VLAN number. So this will be 0, and this will be 0, and the VLAN, whatever the VLAN, for example, VLAN number 20. And then after that, you will have a layer 3 header. Source IP 101, destination IP 102, and then ICMP protocol number 1. This is your header. So this will be your Ethernet header. This will be 80.1q header, this one. And then there after that we have IP header. So guys, we were discussing about the tagging protocol. Why do we need of tagging? So that switch can easily identify where should I forward the packet. So at the same time, whenever you're going to make a trunk, right, you need to define the tagging protocol as well as, because by default it's enabled with the word ISL. You have to change with this guy. I say the hey switch put trunk encapsulation 80. Why am I to call this term as encapsulation? Because this whenever the packet is coming, right? So take example, this PC will send a packet. They have a source packet as A and destination packet will C out. When this packet is coming to the 0/1 interface, I'm not going to perform any kind of tagging over there. Tagging will be done on 0/3. When this packet is going to place on the 0/3, what happened? The trunk will add the tag, the VLAN number 10. So if you're adding something, right? Adding means what? Doing the encapsulation. Adding the extra header is called encapsulation, and removing the extra header is called decapsulation. And your complete OSI model is depend on the, if somebody will ask you, hey, explain me the OSI model in the 2 words, the complete OSI model is going to do the encapsulation and decapsulation. All good, guys. So now on this particular interface, I will perform the tag over there. When this packet will switch to, will forward the packet to the switch 3, sorry, switch 2. Switch 2 will receive this packet on which interface? 0/3. So this packet is coming like this over there, A, B, and VLAN number 10. What happened? Once the switch 2 will place this packet on the this interface 0/1, right? They will send this packet A and B only. So VLAN tag will be happen over there. Adding and removing will happen on the over there. Encapsulation and decapsulation. Tagging is only done by the trunk interface, not the access interface. Access port does not have any idea about the tag. No idea. कुछ नहीं पता होता उसको, कुछ नहीं, फर्क ही नहीं पड़ रहा उसको, बेइज्जत इंसान है. So you can do the, as I told you that you can have a 2 encapsulation protocol. Either you can do the ISL or either you can go for the 80.u. Same way, trunk you can configure in the 2 ways. One we have a static, one we have a dynamic. For the dynamic, we have a protocol that is called as a DTP. The first of all, I'll show you this part static, and then I'll go for the dynamic as well as. So let's open the GNS3, where I can show you the Wireshark and everything. All good. So all perfect, right? So let's do one thing. Reduce the lettable size. I'll put it over there. So guys, have a look the topology, right? And let me know if you have any questions in this topology, right? So we have a switch, same topology I did, switch 1, switch 2, and VLAN number 10, we have IP, VLAN number 1, 1 or 2, VLAN number 10, 103, and VLAN number 1 of this guy. तो मोना का काम ऑफलाइन दिया गया घर से। So IP interface brief, we have this interface 0/0 101, okay. And then if you go for the router number 2 as well as this guy. And guys, this is not a PC actually, this is the router, and I made this router as a PC. You see the default, he's asking for the default here. So IP routing is disabled over there. All good. 102 now, 103, this guy, R3, this guy. And this guy should be 104. All good. So what we have to do on our switch right now, if you see, okay, I have a switch one. Let them start. Okay. And let's capture this link. One more thing. Native VLAN. That is VLAN number 1 by default. Does not perform any kind of tagging. You can change the native VLAN. Untied, exactly right. Untied ID. Now, if you go on a router, okay, let them start. It's taking so much time, man. So if I'm going to ping from here to here, right? The VLAN number 1 to the VLAN number 1. This guy to this, sorry, not this one, this one. They will not perform any kind of tag. This is the same VLAN, right? Not perform tag. Let's do one thing. Let them start. सोचो ठीक है, सब तुम सोचो, बोलो मत, ठीक है यार। रुको नहीं यार, तुम बना रहे हो फालतू का। Let's start, man. Come on. Switch. I think so. This is switch to, yep. हाँ यार। Question switch one, right? That's it. That is the best option. Oh, bro, yes, bro, yes, 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 yes. वो देखो दे दो. Interface gig 0/2, right? I'm going to make this interface Okay, before I'm going to make the interface trunk. Okay, let's make it then. Switch port trunk encapsulation. You can see I have two options over there. One is the .1q and another is the ISIL. I'll explain you this part later on. Okay, one is the .1q, we have the protocol, and one is the ISIL over there. This is an encapsulation protocol, guys. What is the meaning of encapsulation? Adding the extra header is known as a encapsulation. And removing the extra header is called as a decapsulation. I'll say that 80.1q, right? And after that, I set the switch port mode trunk. Same configuration, do show history. I need to do on the switch 2. All done. Now just wait for some time. Show interface. If you now look that is this interface become a trunk or not, you can have a look. Show interface trunk, and you can see the which interface is trunk 0/2. Okay, and leave it the mode right now. The encapsulation is a 80.1q, and the status is trunking. By default, the native VLAN is 1. You can change this VLAN, native VLAN as well as gig 0/2 is going to carry all the VLAN traffic, right? By default, all VLAN is allowed. By default, all VLAN is allowed. We will see that in the later class. I'll show you how we can filter this thing as well. Based on the requirement, you can do the filtering on the VLAN. Okay, we'll see that. Right now, I'm just trying to clear the concept of what is trunk. All good. And at the same time, if you want to see the show interface trunk as well as on a switch 2, it is the same thing over there. And if you see the show interface gig 0/2 switch port, this interface is a layer 2 interface, and the mode is trunk. And this is the mode is administratively I've defined over there, right? The protocol I'm going to use the .1q. Now, if you send the packet from the PC number 2, right? Go on PC number 2 and send the packet ping 10104, right? Here to it. VLAN number 1 to VLAN number 1. See? Are you able to see any kind of tagging over there? No. Source MAC, destination MAC, and the type. And actually we have all this one. There's no tagging, right? Well, sense even those. So I'll do one thing, guys. I'll take a snipe of this person, and so that I can, uh, correlate with the tag protocol packet, right? Okay, so that you can easily identify those things. So we have this one, and I'll paste it. Do I have a space somewhere? And now at the same time, now we have a trunk on this particular interface. I'll do one thing. I'll go to router number 1, this guy VLAN number 10 to the VLAN number 10. I'll ping from here. 3. And here we have to go. Come on. Yes. And if you see echo request, and okay, it should not be, this one should not be. So 101. Achha, I haven't configured the VLAN, right? 1 minute. Let me add the VLAN. Interface gig 0/0. This interface, right? Gig 0/0. This VLAN number 10. Switch port access VLAN number 10. And the same thing, gig 0/0 over there, right? This is the VLAN number 10. Interface gig 0/0. Switch port access VLAN number 10. All done. This is the VLAN of 10, and here we have to do over there. Bingo. Now let's send the packet. Come on, wake up, wake up. Come on. It's taking some time because of the span tree is running on over there, right? Yep. And here we have done, and this is all done. See the difference. Can you see that? In this one, he's saying that, hey, Ethernet header is saying that, hey, I need to forward the packet to whom? IPv4. That's why we have a IP. But now the Ethernet header is saying that, hey, need to forward the packet to whom? 80.1q protocol, right? The type is a 0x8100. The size is, what is the size of this guy? 2 byte, 16 bit, right? And then that's why it's forwarding the packet to whom? 80.1q protocol. The priority will be 0, the cost field, the quality of service, always set to the 0 until or unless you're not going to define the priority. Cadencial format identifier CFI, or we can say the DAI, always set to 0 for the Ethernet VLAN. For the different types of VLAN, the tokening, it will be different. For the Ethernet, it is going to represent 0 over there. And ID will be what? VLAN number 10. This is the ID over there. So the size of this guy is what? Type 16-bit. This guy, the VLAN number 10 is a 16-bit, right? This is the 1-bit, 3-bit. Here is this is a 12-bit, 12-bit. 12, 15, 16, 16, 32. 4 byte. And then he's saying that, hey, I need to forward the packet to whom? He's saying that I need to forward the packet to the 80.1q. That's why I'm forwarding the packet to the 80.1q. And after that, he's saying that, hey, I need to forward the packet to whom? IPv4. And now we have a IPv4 over there. This is called as a tagging. This is called as a so only on the access, if you see over there, if you capture this link on the access port, right, there is no tag. On this link, there is no tag is happening. If you see, I'll send the packet. See, are you able to see the tag over the access port? No, there's no tag over there. How many VLANs can be created on the single interface? Are you talking about like the access port or trunk port? Access port, you can have a two, like one for the voice, one for the data, and on a trunk port, like what is the range of the VLAN? By default, 4094. On the trunk port, access port, you will have a data will be one and voice will be one. All done. Same way, if you have a look right now, the default native VLAN is one, right? Let's do one thing. What I told you that native VLAN does not perform the tagging, right? I'll do one thing. I'll see the interface. Okay, 1 minute. Gig 0/2 now, this interface, right? Switch port, trunk, native VLAN. I'm going to make the train over there, right? Same thing I'm going to do on the switch 2 now, because native VLAN should be stream, right? So gig 0/2 now, and this side as well as native VLAN should be same. That's fine. Do show interface strong now. And now if I'm going to forward the packet, have a look, repeat 100. See, there will be no tag. Are you able to see the tag over there? No tag is happening. Same packet is there, right? Can you see that? Same 103 is there, right? 101, 103. There was a tag over there. Same one is there. There is no tag. Nothing tag is happening. No tag. Because native VLAN does not perform the tagging, right? I made this guy as a native VLAN. But now if I'm going to ping from this guy, right? Here to here, VLAN number 1 to this guy, they will perform the tagging now. See? See that? The VLAN 1 tag is happening for the VLAN number 1. Always remember, native VLAN does not perform the tagging. Never. Guys, anyone has a question till this point?
So if we configure native VLAN only for that VLAN, tagging will be not performed, right?
Of course, yes, yes. Sure, when we do, sir, when do we use the native VLAN? By default, the native VLAN is used. By default, the native VLAN is using, right? You don't need to apply, you don't manually configure it. In what way you're asking? I didn't get your question. By default, native VLAN is present. You don't need to configure it. I just show you the one behavior, right? If your native VLAN is if you can change the native VLAN, and for the native VLAN, there does not perform any kind of tag over there. But if you have one condition, I can show you 1 minute. I'll show you one condition. That take example. The camera is cut off. I'll do it. नहीं, इसको नहीं हटाऊं.
So by default, our native VLAN will be 1. So based on that, when we are communicating between VLAN 1, so tagging will be not performed, right?
Yes. And now I'll do one thing. Take a switch. This guy. Done. And I'll remove this PC. So this guy has IP address will be. Let me check what is the IP address of this guy. It's a 101. And what is the IP address of this guy? 103. So IP address is this guy 101 and IP address is 103, right? And I'll do one thing. I'll make this guy as a VLAN number 10. And let's get this guy as VLAN number 20. Can they communicate? Yeah, tell me. Can they communicate?
No, sir.
Right? And this is 2 now. This interface 0/2. So if you see, if I want to send the packet from here to here, 103, right? Thing will not work. because both are a different VLAN, right? And even if you see the packet where I'm dropping, capture, and the packet has dropped on this side, right? Now, let's do go to switch to switch 1, switch 3. And what I'm going to call interface 0/2 now. Switch port mode trunk. Switch port trunk native VLAN 10. This side I'm going to tell this guy interface 0/1 switch port mode trunk and switch port trunk native VLAN 20. Now if you see, it will work, don't worry. Come on. It's good. 9, so it's native VLAN 10. Yeah. Oh, my bad. Just last one. Sorry. Come on, man. एक मिनट ना यार 0/1 I've removed the trunk from there, right? एक मिनट 0/2 this interface, right? 0/2. So 0/1 should be trunk. That is good. 0/2 should not be trunk, right? So now your trunk interface 0/2. Okay. And those will then take 0/2. Now simplify. So see, do you know why this thing is happening? There are different VLAN. It has to be inter-VLAN routing, but I'm not doing the inter-VLAN routing, but it's working because the native VLAN is what over there? Understand the flow over there. Native VLAN is 10 over there. Native VLAN is 20. Native VLAN does not prefer tag. Right? So in this case, what happened? If this, take example, this is MAC address A, this is MAC address B, right? The source MAC address will be what? A, and destination MAC will be what? B. When this packet is coming to the PC number 1, send the packet to the switch 1 will learn the MAC address on this particular interface 0/1. Okay, I will learn the MAC address A, right? And after that, what? On 0/2 interface, the native VLAN, right? Do I need to perform the tagging over there? No. It's a native VLAN. I don't need to perform the tagging. So what happened? So same packet will come on the 0/1 interface. Once the 0/1 interface, this guy, the native VLAN is 20, right? So whenever switch will receive untagged packet. It's a frame, not a packet. Untagged frame. What switch will do? Broadcast, we can say that, or send the frame into native VLAN. So switch 2 is receiving a which frame? This is the untagged frame, right? This frame is received on the switch 2 on this particular interface. What switch 2 is assuming? This is the untagged frame. I need to forward the packet in which VLAN? VLAN number 20, because VLAN number 20 is the native VLAN. Untagged frame switch will send the packet into the native VLAN. And that's why they can communicate to each other. And this kind of question they will ask you in the interview as well as. Guys, question.
Practically, we will not implement this.
Oh, we are not practically. We are not. I'm just trying to show you the concept of the native VLAN. And I'm not done with the native VLAN. We have something more that we'll see in the security part. Native VLAN it will carry the traffic when the VLAN is different. It's carrying, but it should be different on the both side, right? The native VLAN. Then they can communicate to each other. This is just a one logical, right? Hypothetical. The scenario is there, but this kind of scenario will be not there in the production. But they in the interview they can ask you this kind of question, right? So you have to explain whenever the switches will receive the untagged packet, right? What switch will do? It will send the packet into the native VLAN. And who is the native VLAN? The VLAN number 20 is the native VLAN over there. All done. Any questions, anyone, guys? No?
Sir,
Yep.
sir, if we configure native VLAN on a switch 3, so only for that VLAN it will not use the tag. For others, it will.
Yeah, other it will use the tag. Other it will use the tag.
Okay.
Only for that particular VLAN they will not for the tag.
Yes, sir.
मान लो कि take example कि तुमने VLAN if you configure the VLAN number 10 is the native VLAN. So for the native VLAN there is no tagging. For example, if you change the native VLAN 100, so for 100 there is no tagging. For example, you make the 150. For the 150 there is no tagging. Except all them they will perform the tag. And you will only perform the one VLAN as a native VLAN on a one trunk interface.
Okay.
So
Sir,
guys,
in which
yeah,
implement,
yep, go on, tell me.
sir, in which scenario we implement this?
We that what I told you that I'm just taking a hypothetical scenario, right? Just explaining the native VLAN. This is we are not using in the production. They will ask you, they will check your knowledge, right? Do you have a knowledge of the VLAN or not? So they will ask you this kind of question in the interview. I just draw the one scenario and showing you. That's it. We are not using this kind of option in the production, never. So guys, here I'm not done with the trunk. We still have a DTP protocol and many more things about the, like, we haven't configured. I think I thought I have I done with the, like, the VLAN state, right? I thought, right, but it's not. So we'll do one thing. We'll do a complete tomorrow. We'll do the VLAN state and DTP protocol as well as. All good?
Hello, sir.
Yes.
Hello, sir.
Yes.
Sir, Prashant here actually. Sir, if you have any DNS videos, means can you please share it through Drive, sir?
लेना
DNS.
अभी दिया
हाँ?
अभी दे रहा हूँ ले
ठीक है सर.
अभी ले 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 मैं फिर तुम भूल जाऊंगा
कर दो सर. सर और एक चीज है सर, आप